Okay, so on this one, last section of probability, it's really counting principles. We're going to find out how many total number of outcomes are possible. We're going to be using several different methods, but we're going to be referring to factorials, permutations, and combinations. And the biggest, it's not the computation, it's not pumping it out, that's not the hard part. The hard part is determining, is it a permutation or is it a combination? Okay? So, with that said, fundamental counting rule here. And we've kind of used this, we've just not said it. So, the fundamental counting rule says that when I start selecting things, how many different ways can I find something? We use something called the factorial symbol. And we do that when we have a first event can occur so many ways, the next event can be one less, the next one less, the next one less, the next one less. For example, one of the key things here is, one of the words is order or arrange. Those are key words. So, just trying to think something that won't make sense. I have 5, no, this one's 4. I have 4 different Santas. I have a collection of Santas. So I'm going to have 4 of them that are going to sit on my mantle. I want to know how many different ways I can arrange those 4 Santas. So Santa A, B, C, and D. So we could sit and write that diagram out, but let's pretend we're in that situation. The first time that I'm going to pick from that group to put Santa first, I'm just going to pick, how many am I picking from? 4. So I have 4 different possibilities to choose from, correct? How many do I have left here? 3. So the next time I choose, I have 3 possibilities. So there's my second choice. How many do I have left now? 2. And lastly, there's only 1 left to put up there on that mantle, correct? So that's where we're getting 4 times 3 times 2 times 1. And that is called 4 factorial. Now, if you bring up your calculator, I just want to show you where that is on your calculator. So 4 factorial, I got to find it on this, I'm going to type in a 4. I'm going to go to the button that says math, and I'm going to cursor to where over here on the right hand side where it says PRB, that means probability. Everybody see that list? Same list I'm seeing? Well, obviously, just so happens that number 4 is the factorial symbol, but it's right there, okay? So you're going to come down and either choose number 4 or cursor down and hit enter. So I'm going to choose number 4, takes you back to the home screen. It says 4 factorial, so I don't have to punch in my calculator, 4 times 3 times 2, okay? And of course, when I enter then, of course, I'm going to get 24. 5 factorial. So I can do that simply by going 5, math, probability, and number 4 for the factorial symbol, and that's going to be 120. So that would be 5 times 4 times 3 times 2 times 1, but of course times 1 is itself. Okay? So it's not the calculation that's difficult. It's going to be deciding which of these that I'm going to use, okay? So let's continue. So and here's where it goes in and gives you the formal thing about the factorial rule, which we just kind of tried to make sense out of it. It reflects the fact that once the first item is selected, you have one less to select from. And that's what we did when we talked about those 4 Santas and arranging them on that mantle. Okay? So then there's permutations. Permutations. This is where order matters. And when you read one and you're trying to figure out, that's what you need to be asking yourself. Does order matter? Now, if it says how many ways can I arrange books on a bookshelf, that's order. Order matters. If I say that we are going to have a statistics club, and in that statistics club there are 20 people, and we are going to select a president, a vice president, a secretary, and a treasurer. The first person I randomly select from that group, how many possibilities am I choosing from? How many students were in that group? 20. And the first person I pick is going to be president. How many people are left? 19. The second person I pick is going to be vice president. Okay, so now I'm down to 18. And the next person I pick is going to be secretary. And lastly, I'm down to, and then I have to choose the next person who will then be treasurer. Does the order in which I choose matter? Don's thinking, he's saying yes, he's almost committed. Yeah, why? Right, if I picked only the first person I pick can ever be president. So the first one is assigned the president. I can't take the fourth person I pick and make them president. The order that I pick them matters. The order that I choose them matters because I'm assigning them a role. I'm assigning them a role. Okay? If I take that same group, 20 students, who are in my statistics club, and I say, okay, I'm going to pick 4 of you randomly who get to go to San Diego with me for the conference. Would it matter what order I pick them? No, it wouldn't, because it doesn't matter if you were picked first, second, third, or fourth. You still get the same level of what everybody that was picked got. You get to go to San Diego. Okay? Does that make sense? So it depends upon if I'm assigning roles or I'm selecting a subgroup where order wouldn't matter. They all get the same thing. Okay? So those are some of the questions you need to ask when you see these counting problems. And here is the calculation for permutations when order matters. So let's go to our calculator. And we'll compute the one that I just talked about where ordered matter, where we have 20 students in our stats. The first person I pick will be president. The second person is vice president. The third person is secretary. And the fourth person I pick will be assigned to be the treasurer. Order matters. Well, that's what this permutation means. N is the number I get to choose from. So I have 20 to choose from. And I'm going to do a permutation because order matters. How many am I choosing? President, vice president, secretary, treasurer. 4. And I could do this calculation. N is 20 factorial divided by n minus r. R is this, so it would be 16 factorial. That's what that means. Okay? But in our calculator, so you know how to do it, I'm going to first type in 20. I'm then going to go to math. And again, over to probability. And I'm going to choose NPR, not the radio station, right? NP and R, because it is a permutation. So that's the one I'm going to choose. It takes me back to my home screen, and then how many people am I choosing? 4. And I'm going to hit enter. Wow. 116,280 different possible ways for there to be president, vice president, secretary, and treasurer because order mattered. Okay? Is that making sense? Okay. All right, let's keep going. This is when I have a situation. Now, the last situation, each of those students were individuals, so I didn't have 2 identical things, correct? So that's why I could just go with a straight permutation. This occurs when I do have something that is identical. So we can go back to those Santas I talked about. Let's say that I wrote a question here. I have 10 Santas. I have 2 are alike. And then I have another 3 that are alike. So, because if Santa A and B are identical, if I take A or B or B or A, they're really the same order, aren't they? Because they're identical. So I have to allow for that. So the way that I'm going to compute that is I'm going to say 10 factorial divided by the number of items that are alike. 2 factorial and 3 factorial, okay? So if I do that in my calculator, I'm going to punch in 10, go to math, go over to probability, I'm going to choose number 4 factorial, then I'm going to take that answer and I'm going to say divided by, and I'm going to put in parentheses. So I'm going to start a parenthesis here, 2, math, probability, I'm choosing the factorial symbol, and it will assume multiplication, 3, math, probability, and factorial. Close your parenthesis and hit enter. And I'll save that screen on there. Okay? So that's when you have 2 that are alike. Okay, so here's the combination. And we talked about it already. We said, hey, order doesn't matter. Order does not matter. I have 20 of you. I'm randomly going to select 4. And those 4 all get the same treatment. They all get to go to San Diego. Okay? Combination, because it doesn't matter about your order. And here's the formula. But in that case, I'm going to write 20. Combination, choose 4. And I can go and get that in my calculator just like the other ones. I'm going to do 20, math, go to probability, and this time I'm going to choose number 3, NCR. And again, I'm going to choose 4 out of that 20. So it would be 4,840 different possible outcomes. Much less than a permutation. Remember, permutation was what, 116,000 something. Okay? So again, I have to ask myself, does order matter or order does not matter? That is how you decide whether you're going to be doing a combination or a permutation. To me, that's the toughest part because the calculation isn't difficult, right? Okay, here we go. History pop quiz. Ask students to arrange the following presidents in chronological order: Haynes, Taft, Polk, Taylor, Grant, Pierce. If an unprepared student totally guesses, what is the probability of guessing correctly? How many ways can I do that? How many different possible ways could I arrange those, and would order matter? Absolutely, because I'm telling you I want them in chronological order. So order matters, right? So how many different ones? 1, 2, 3, 4, 5, right? 2, 3, 4, 5, 6. So it's 6 factorial is the number of ways. What is 6 factorial? And how many correct answers are there? 1. So the probability is 1 out of 720. Yeah, not much, huh? Oh, sorry. Just let me let her know I'm in class. And she's typing a message she didn't know. Okay, here we go. In the Pennsylvania Match 6 Lotto, winning the jackpot requires you to select 6 different numbers from 1 to 49. The numbers can be drawn in any order. Am I using a permutation or a combination? A combination. Just as long as I get those 6 numbers, I win. I don't have to have them drawn in a certain number. As a matter of fact, when you see results of Powerball or Lottos or whatever, they just put them in numerical order. That's all. They didn't draw them in that order. Okay? So what am I going to do? Find the probability of 1 ticket is purchased. What are you going to do? How many numbers between 1 and 49? 49, because I don't have 0. I don't have 0. So 49 possible. And it's a combination, permutation? Combination. And how many do I have to get right? 6. And that's the last slide. So 49. Going to go to math, to probability. And I'm choosing 6. Wow, yep. So 1 out of 1.4 million. Okay, everybody, don't forget. Just put 1 over that number. Okay? Okay, don't forget, you're going to pull those practice problems and bring them with you for class on Wednesday.